myself Naveen Kumar. Have 12 years of experience, IT experience in the software field. Let us come back to your microservices Spring Boot. So today's the agenda is that we are going to discuss why microservices, what is microservice architecture, feature of microservice architecture, advantages of microservice architectures, and companies using microservices. And finally, you'll be able to see the hands-on of the microservices. Now we are going to understand why microservices, then you'll understand in detail why there is a need of microservices or why there is a need of Spring Boot. Before understanding Spring Boot or microservices, first let us discuss about monolithic architecture. So when you come across this monolithic architecture, let us explore the concepts of microservices through a use case of MediaMore.com. So here, MediaMore is an entertainment company which provides streaming media and videos online. It consists of various genres of TV shows in different languages. Like many other companies, MediaMore started its journey with a monolithic architecture. So whatever the diagram you're seeing this, it's a monolithic architecture. In this diagram, you can see, you can refer that all the features such as here you can see the architecture like HTTP request, you have a server-side application and all the HTML views to be sent to the browser, which a client-side UI, and you'll be connected to the database. Okay, now let us come back to this one. This will looks pretty better. So when we see in this diagram, you can see that search you have customer service, product service, and cart service, which have taken a classic use case of a e-commerce application. So here, the challenges in monolithic application. What is the challenges in the monolithic application is that number one, let's assume that the developer wants to update. Let us say I was saying you the customer service. They want to update the product service according to the latest product which is available in the market, and also simultaneously want to update all the cart services provided in the application and whatever the customer service. The developers cannot scale the application simultaneously. New instances of the same application have to be created every time a new feature has to be developed or deployed. Second thing, when you come across these challenges in the monolithic architecture, the monolithic application can definitely accommodate those changes, but the problem here is that the developer have to rebuild the code for every small changes in order to reflect. The third one is called as an hybrid technologies. What is meant by hybrid technologies? Suppose developers of this application are comfortable with various technologies like Java, C++, or .NET and C#. Even though they are comfortable with various technologies, they still have to build large and complex application on a single technology stack. Fault tolerance. Let's suppose that a specific feature is not working in the application. The complete system goes down because of this problem. In order to tackle this problem, the application has to be rebuilt, retested, and redeployed. So this is how the challenges faced by the developers. To overcome these complexities, developers then thus decided to re-architect their monolithic application into multiple individual deployable components called as an microservices. Hope so you got an idea what is microservices. So now we'll understand what is microservices. This is the challenge which I said you here. Okay, slow development and all. So now we'll understand what is microservices. Microservices is an architecture wherein all the components of the system are put into individual components, which can be built, deployed, and scaled individually. Let me explain you with a simple analogy. You must have been seen how bees build during their honeycomb by aligning hexagonal wax cells. They initially start with a small section using various materials and continue to build a large beehive out of it. These cells forms a pattern resulting in a strong structure which holds together a particular section of the beehive. Each cell is independent of the other, but it is also correlated with the other cells. This means that damage to one cell does not damage the other cells. So bees can reconstruct these cells without impacting the other complete beehive. So based on this diagram, you can see this diagram here. Each hexagonal shape represents an individual service component. Similar to the working of bees, each agile team builds an individual service component with the available frameworks and the chosen technology stack. Just as in a beehive, each service component forms a strong microservice architecture to provide better scalability. Also, issues with each service component can be handled individually by the agile team with no or minimal impact on the entire application. The next question that may come to your mind is, how do the different components of microservice architecture work together? So now we'll understand the microservice architecture in this particular diagram. Now when you see this diagram, we have a client, we have an identity provider, and we have API gateway, CDN, and we have static content management and all. So what is meant by a client? Different users from various devices sends request. Identity providers authenticates user or clients identities and issues security tokens. API gateway handles client request. Static content houses all the content of the system. Management, as you can see, the management balances service on nodes and identifies failures. Service discovery, a guide to find the route of communication between microservices. Content delivery and network, CDN, distributed network of proxy servers and their data centers. The last one is your remote service, enables the remote access information that reside on a network of IT devices. Now this is about this architecture. Now let us understand in much more scenario. Now let us say Alice is an avid user of MediaMore. She uses MediaMore regularly to watch her favorite series online. Like MediaMore means you can assume it as a Netflix or Amazon Prime. She recently missed watching an episode on her favorite TV show. When Alice logs into the application, she sees the most recommended content on her home page. After some searching, she finally finds her TV show. But what if Alice wants to get her TV show with a single click? How will the developer work together to fulfill Alice's request? Alice's request is passed on to the identity provider. Identity provider thus authenticates Alice's request by identifying her as a regular user on MediaMore or Netflix. These requests are passed to the API gateway, which acts as an entry point for Alice to forward her request to the appropriate microservice. Each feature has its own working microservice handling their own data. These microservices also have their own data balancer and execution environment to function properly. Each microservices is handled by a small agile team such as content team or video uploading team, most trending team or searching team, etc. The content team consists of millions of TV shows that the application provides. The video uploading team have the responsibility to upload all the content into the application. The most trending team houses the most trending shows according to the geographical location of users and so on. These small teams of developers relate each and every piece of content with a metadata that describes the search content. Then metadata is fed into another microservice, that is the search function, which ensures Alice search results are captured into the content catalog. Then the third microservice, that is most trending microservice, captures the trending content among all the MediaMore users according to their geographical location. The content from the microservice is what Alice sees when she first logs into MediaMore or Netflix.com. This individually deployable microservices are put into specific containers to join the application. Containers are used to deliver the code to the sector where deployment is required. But before they join the application to work together, they have to find each other to fulfill Alice's request. So this is about microservices. So microservices use service discovery, which acts as a guide to find the route of communication between each of them. Microservices then communicate with each other via stateless server, that is either by HTTP request or messaging bus. These microservices communicate with each other using an application programming interface, that is your API. After the microservice communicate within themselves, they deploy the static content to a cloud-based storage service that can deliver them directly to the clients via CDN or content delivery networks. So when Alice searches for her TV show, the search microservices communicate with the content catalog service in API about what is Alice is searching for. And then these microservices compare the type words with the metadata they already have. Once the team of developers captures the most typed words by Alice, the analytics team update the code in recommendation microservice and compares Alice's most viewed content and preference to popular content among other users in the same geographical region. This means that the next time Alice logs onto the application, she not only sees the most popular content but also finds a personalized playlist which contains the shows she has previously viewed. In this way, Alice's request is fulfilled by the development team in a quick manner, as they did not have to build the complete application again and just have to update the code to deploy the new functionality. So this way, microservices involves parallel environments to satisfy millions of customers with varying interest. Understood what is microservice and all? Okay, people who are asking companies, okay, companies using microservices. The first companies, Netflix, as you know, it is a web series channel, but in order to develop your microservice or this one cloud-based Spring Cloud or Spring Boot, if you heard Spring Cloud, they use Netflix libraries. Okay, and apart from this, we have Amazon, Site, SoundCloud, Uber, Twitter, PayPal, eBay, Guild, The Guardian, Nordstorm, all these gigantic companies will use microservices in their applications. So hope so you got a fair idea of microservices. So now this, I told you the architecture. Now how do we implement this architecture with a technology called as a Spring Boot? Okay, with a technology called as a Spring Boot. Okay, now I'll show you a demonstration of microservices, which you will get a fair understanding about microservices. Now let me take, so whenever you want to develop a microservice, now I choose patient patient microservice Edureka. Let me have underscore symbol. Let me click on next. So before starting this patient microservice system will have Eureka server. So when you provide this Eureka server, I'm trying to give Eureka server snapshot demo project for Spring Boot and all. Let me click on next. So here, when I choose here, I need to have only the Eureka server. Okay, I choose the Eureka server. So when I click on next and finish, you can see this in the search window. You can see Eureka server. Let me close all this file. And when I expand this Eureka server, okay, it is downloading the content. Now it is taking some time. So let me open your application.properties. Here, this is the file where you are trying to property. I try to give the port number, server.port. So by providing this port number, I'm trying to mention server. Okay, it's taking some time. Since it is creating this project, let us create one more project. So in this project, I try to have a project called as an item catalog. Let us have it in JDK8. So let me click on next. And I try to give H2 database. And apart from this, I try to give discovery. And we'll have dev tools. I'll use Lombok API. Spring Boot actuator. GPA. Okay, and you have REST repository. Okay, I have given this all these values. Let me click on this finish. Okay, it is taking some time in the Eureka server. Okay, till the time that application loads, let me go back to here and try to update some values. So what I was planning to write it here means I was trying to give server dot port. So what is this port number for Eureka server? That is 8761, and this particular port number it will work. And you have Eureka dot client dot register with so where I am registering this I'm trying to give false because it is a server. That's where I'm trying to disable the registration. That's where I provide false. File to add a port number, and for disabling the registration, that's where I mentioned false values. Once I give this value, let me save this file in the port file. Okay, it is taking some time. And in order to make this application client means it is taking some time. For this application loads, let us discuss something on microservices. We have understood the microservice architecture. Now, how we are implementing this microservice architecture? We'll be using a Spring Boot technology. Okay, why there's a need for Spring Boot? Spring Boot enables building production-ready applications quickly and provides non-functional features. Embedded servers which are easy to deploy within the containers. It helps in monitoring the multiple components. It helps in configuring the components externally. So as we have seen the monolithic application challenges, only the problem in the microservice architecture is that while developing a number of smaller microservices might look easy, but there are a number of inherited complexities that are associated with the microservice architecture may face the challenges. So for example, if you're trying to automate the components, it becomes difficult to automate everything because there are a number of smaller components instead of a monolithic that is build, deployment and monitoring, etc. Perceptibility. There are a number of small components to deploy and maintain, which sometimes becomes difficult to monitor and identify problems. It requires great perceptibility around all the components. Configuration management. There is a great need to maintain the configurations for the components across the various environments. In terms of debugging, it becomes difficult to probe each and every service for an error. Centralized logging and dashboards are essential to make it easy to debug problems. Consistency. You cannot have a wide range of tools solving the same problem. While it is important to foster innovation, it is also important to have some decentralized governance around the languages, platforms, technology, and tools used for implementing, deploying, monitoring microservices. So that's where we are developing an application, that is Spring Boot microservices, by using Edureka server. So here Edureka service, whatever we have created the Edureka service, let us understand. This service will register every microservices, then the client microservice will look up the Edureka server to get a dependent microservice to get the job done. This Edureka server is owned by Netflix, and in this Spring Clouds offer way to register and invoke services by Java registration. So what you are trying to do here means, if I go to your source main Java, and if you click on this Edureka server application, you are trying to give on top of the application, that is at Edureka at enable Edureka server. That's it. You are trying to provide this annotation above Spring Boot application. So now once the application is ready, right click, run on Spring Boot application, or you can run as Java application. Now you can see the server is running. So once the service is there, you can see with the Spring Boot, it has an internal embedded Tomcat server, which is running in a port number. So once the server is running, so in order to verify this port number, you can open here http://localhost 8761. Press enter. So this is called as an Edureka's dashboard. Okay, and you can see the environment. Okay, I have not configured any environment or data centers. So default current time and all, you can see the instances. Now I'm going to create an item service, catalog service. Once after this catalog service has been created, whatever the independent service, it will get registered with Edureka. So once the server is ready, now you have seen this item catalog. Let me expand this item catalog. So you remember just now when I was creating this catalog, I was choosing a few of the things. Like when I was providing here, let me open your um, okay, when I try to create a catalog, I forgot to change this one. Let me delete this because I have given the Gradle application. Let every application be on the same page, not Gradle. Let me choose it as a Maven item catalog. Then the rest of the things. As I choose you couple of things. What are the items which I choose? I choose actuator. Then I given discovery. Then I choose JPA for Spring Data JPA. H2 database. Then I'm trying to provide REST repository. Web. Okay, I'll try to provide Spring Web. Okay, you'll have dev tools. These are the things. Okay, and also if you have Lombok, It will be well and good. Anyway, I'll explain this. Actuator. I choose the actuator. What is the Spring Boot actuator? Helps features to help you monitor and manages your application. You are able to manage this application with help of actuator. Features to help you monitor and manages your application. Now we are using Edureka Discovery for service registration. JPA. I choose JPA here to save and retrieve data. H2, which is an internal memory database. I have used REST repositories to expose JPA repository as REST endpoints. Web. Spring MVC and embedded Tomcat container is present. We have used DevTools. What is a Spring Boot DevTools? To auto reload the application when file changes. And one more feature was a Lombok, which I was trying to use to avoid boilerplate. Okay, anyway, Lombok is there. Okay, what is the use of Lombok means? To reduce boilerplate code. Okay, let me click on this finish button. You can see this particular application is getting created. So when you see this item catalog, you can see this file. Let me choose new, a package. So here I try to have, let me have the class, okay. We have com.example.demo and I try to have entity. Here I am trying to provide item. Okay, let me click on this finish. When you have this class, I try to use certain annotations called as in with help of Lombok. I'll use @data at all orgs constructor. What is the difference between data means it will provide you the getter setters and no argument constructor. At all constructor means whether okay, let us import this package and I try to have you have all constructor, and if you want to have no argument constructor you can give no argument constructor. Okay, you can import control shift O and you can provide @toString. That means earlier we used to write all this toString method, right? Here we no need to write because the Lombok API is avoiding all this boilerplate code. Control shift O. If it is not there, not a problem. Now have defining a name. Let us say private string name. And if you want to have private long ID. So I'm trying to have @ID and I try to provide @generated to have a foreign key value, sorry, primary key value. Control shift O. Okay, we have imported all this name. And if you want to have a customized constructor for this, I'll try to give constructor only for name. I doesn't want to have ID. I try to have a constructor. Let me remove this super keyword. That's it. Okay, Control S. You can have this name after here. Now, if you want to have repository REST resources, right? You can have one class. Let us import this package .rest. I try to provide the name, not class. Let it be interface. So here I am trying to provide item repository interface. When I'm trying to click on this item repository, I'll be using extends JPA repository. What is the use of JPA repository? It will try to provide the CRUD repository I'm using this GPA. Okay, these repositories I'll be using at repository REST resource. Okay, we have created this repository and we'll have one class. So I'll have a class called as an item initializer. So when I give this item initializer, this is the class, and I try to provide a stereotype annotation called as an @ component. This component which will implement command line runner. Okay, Control Shift O. Since this class has one particular abstract method, let me implement that boilerplate code. That is the run method. So in order to run this run method, I try to have one item repository reference. So in order to initialize this variable, we need to have a parameterized constructor using fields, because it is a final variable where I have initialized this variable. So when you use this run as, I try to use a stream function. I'll use a off method where I'm passing the string arguments, like let us say something called as lining, Puma, shoes, brand. Here's Jordan. Okay. Now whatever this items have been added, let us say you want to add Adidas, and I'll have Reebok. So once you have added all this element, I try to call an terminal operation called as an for each, and I try to have item lambda expression, item repository, dot save method. Save. I'm trying to call new item, whatever the given item. That means I'm trying to insert all the records here. Control Shift O. I'm trying to import that class. So once it has been saved in the record with the help of this item repository, the first line indicates for saving, the second line is for retrieval. So I'll be using item repository dot fetch all. You have a method called find all. In this find all, I try to retrieve all the elements. So I'll use method reference system.out println. So whatever the record which is present in the database, it will start iterating and print. So now in order to run this, we have written the business logic. Let me save this file. And if I open my resources in the application.properties, here you will specify the port number, that is the client port. Let me say I'm running in 8088, and I try to configure this application spring.application. Let us say I try to give application name, that is item catalog service. Item catalog service which have been mentioned. this one. So when I try to refresh this file, okay, no instances are available. So in order to register this service, now I need to register this services. So in order for this, let me click on File, New. I'll choose the other. Here I'll choose the file, that is the general file. So let me add this file. So what I'm trying to define, I try to define all the crowd properties. Like let us say I'll have application dot properties 1. So here I try to provide all the server reference, like let us say Eureka dot instance. If you want to create instance means you can provide the host name. I'll try to provide this host name later, and I'll try to provide instance ID that I'll try to provide. Let us say I'm trying to provide the numerical value, and here I try to use expression language where I try to provide vcap dot application dot instance underscore ID. I try to provide here. So what this ID it will try to read means, when we provide these details, this ID will have an expression language where it will try to have Spring. Let me put it in the next line. Let me maximize the screen. When you're trying to provide this value, Spring dot application dot name application dot name I try to provide this ID. Then I try to provide the server port. Whatever the server port is there, right? That is 8761. I'm trying to add that port number. So when I try to make it in single line, it looks like this. And when you come to this port number, you try to provide whatever the vcap is there, right? I'm trying to mention this URLs. Let us say for 0, the local host. Now this is about client server, that is the cloud instance. Now if I want to make it as a client, I need to mention Eureka client dot region. Let us say I try to provide default. Fetch interval in seconds. that is the numerical 5 are given. So this is the values. Okay, I given this file. Now if I go to this file, okay, in the application, if I go to this file and if I start this application, right click, run as Java application, you can see the service has been started. That is a client service. No, we are not going with the Microsoft Spring Cloud in detail because there is a different session where you will be using the circuit breakers and all linked. So here you are seeing that how you are registering the service. Okay, once you have registered this service, go back to here, Tomcat, refresh this URL. You can see that server which will get registered over here. Okay, 8761. Okay. Yeah, yes, we'll try to have one more edge service. So in this edge service, here you try to have let me click on next. So in this edge service, I try to choose the historics. We'll try to have Eureka Discovery client, and we'll have Zool. Okay, Zool is not available. Will be chosen web, and I need to have Fiend. Okay, even that is also disabled. Okay, basically we were supposed to have certain services in order for registering for historic dashboard. Okay, so here, okay, first I'll explain you theoretically, but I was trying to execute. Okay, let me explain what I was trying to perform. Okay, when we are discussing about the Spring Boot, I'm not using any presentation, I'm telling you verbally. Okay, in the Spring Boot microservices example, we are creating top sports brands application, which will be having three services, where I was trying to have services like Eureka service. As you can see, I was trying to have item catalog, and I used to have Eureka service, and one more was item this one 𝐻 service. Okay, because of my application system limitation constraint, I'm not able to develop this 𝐻 service. Let me tell you what this Eureka service is all about. Okay, this service will register in the Eureka server. This service will register every microservices, and then the client microservice will look upon the Eureka server to get a dependent microservice to get the job done. This Eureka server is owned by Netflix, and in this, Spring Clouds offer a declarative way to register and invoke services by Java annotations. That is where we use at enable Eureka server. When you talk about the item catalog service, what this item catalog service is there? This service will generate the list of sports brands which are popular in the market. The next one which I was creating was Edge service. It is similar to the standalone item service created in Spring Boot. However, it will have fallen up capabilities which prevent the client from receiving an HTTP error when the service is not available. So that is what I was trying to create this head service because of limitation of APIs which was not there, like my Eclipse was not supported. So I'm unable to demonstrate the program of the edge service. So basically what did you understand about this microservice means, where you are able to develop individual service model, and you are able to see each service will be connected to independent database, and with the help of Eureka server you will be able to register all the services, and you'll be using Joule API, which will be like an front when if any incoming request when it is coming to the Joule API will be acting as a common gateway API. It will check, then it will authenticate, then it will be passed to the respective services. Those respective services like item catalog has to be registered in the Eureka service dashboard. That is what I was trying to demonstrate, but because of this edge service limitations, like which is not supported in my Eclipse, I'm unable to demonstrate the demo. But did you got a fair idea about what is microservice architecture? What are the challenges in the monolithic application? How microservices is able to achieve that? It's an architecture pattern. In Spring Boot and Spring Cloud, you will be able to achieve this microservice architecture. So embedded service which are easy to deploy with a container, as I have already discussed, it helps in configuring the components externally. Okay, this is what the Eureka services which I was trying to explain. That is what Eureka service. This service will register every microservice, and then the client microservice will look up the Eureka server to get a dependent microservice to get the job done. This Eureka service is owned by Netflix, and in this Spring Clouds offer a declarative way to register and invoke services by Java annotations. Now we have item catalog service. This service will generate the list of sports brands which are popular in the market. The next service, which is nothing but your edge service. It is similar to the standalone item service created in a Spring Boot. However, it will have fallen capabilities which prevent the client from receiving an HTTP error when the service is not available. So we use the tools like Spring Boot, Oxygen, Eclipse, and we use Java 8 as a JDK tool. Thank you all for participating in this session.